Morning students. Today we are going to discuss surface area and volume. In this chapter, the exercise 13.4, we are going to discuss this exercise, and this exercise relates with sphere and hemisphere. So the important formula that is to be used are already provided. Now let us see the next three questions. The question number 4 says, the radius of a spherical balloon increases from 7 cm to 14 cm as air is being pumped into it. Find the ratio of surface area of the balloon in two cases. Assume pi is equals to 22/7. So we have two different kind of balloons. One is 7 cm and one has the radius of 14 cm, as you can see in the diagram. Now let the smaller radius be R1 of 7 cm and the bigger balloon, the radius be R2 with 14 cm. We have to find their ratio of surface areas. So the formula for surface area of a sphere is 4 pi r square. So the ratio of their individual surface areas will be surface area of a smaller balloon by surface area of a bigger balloon, which is equals to 4 pi r1 square by 4 pi r2 square. Now as you can see, 4 pi and 4 pi in the numerator as well as in the denominator are same numbers and same numerical values, so we can cancel each other and we will get r1 square by r2 square. So as you can see, r1 square by r2 square, we know the values of the r1 and r2. So r1 is 7, so 7 square, and r2 is 14, so 14 square. So we can write 7 into 7 by 14 into 14. Now 7 and 14 are multiple of each other, so 7 ones are 7 and 7 twos are 14. Again 7 ones are 7 and 7 twos are 14. So we will get 1 by 4. So the required ratio of their surface area is 1 by 4. So this was question number 4. Now let us see question number 5. Question number 5 says, a hemispherical bowl made up of brass has inner diameter of 10.5 centimeter. So we have a bowl. And this bowl has an inner diameter of 10.5 centimeter. So this part is 10.5. Find the cost of the tin plating it on the inside of the bowl at a rate of rupees 16 per 100 centimeter square. We have to assume pi as 22/7. So let us see how to do this kind of a sum. As you can see, this is the bowl and the inner diameter is 10.5 centimeter. So we need to find a curved surface area of the hemisphere. The diameter is given, so the radius will be diameter by 2, so it will be 10.5 divided by 2, which is equals to 5.25 centimeter. So as we know, it is a hemisphere, the bowl is a hemisphere, so the curved surface area of the hemispherical bowl will be 2 pi r square as per the formula. We know that in pi we have to substitute 22/7, and in place of r we have to substitute 5.25. So 2 into 22/7 into 5.25 into 5.25. On calculating, we can see that we will get 173.25 centimeter square. So this is the curved surface area of the hemispherical bowl. Now the cost of tin plating we have to find. We have to use unitary method in this place. So the cost of tin plating 100 centimeter square is equals to rupees 16. So cost of 1 centimeter square will be rupees 16/100. Cost of tin plating 173.25 rupees 25 centimeter square will be 1 by 100 into 16 into 173.25. Now, the easiest way of doing this kind of calculation is multiplying the two numbers and then dividing by 100. If we divide by 100, the point shifted to left hand side by 2 places, as there are 2 zeros in the denominator. So we will get 27.72 as our cost of tin plating. So hence our answer will be cost of tin plating the hemispherical bowl is rupees 27.72 paise. So this was sum number 5. Now let us see the last sum for today's tutorial, that is sum number 6. Find the radius of a hemispherical bowl whose surface area is 154 centimeter square. Assume pi is equals to 22 by 7. So we will assume pi as 22 by 7 and the surface area of the sphere is given. So we have to find the radius from this surface area. So let us assume that r be the radius of the sphere, and we know surface area is equals to 4 pi r square. Now the value of surface area is given as 154. So we will write 154 is equals to 4 pi r square, which implies 154 is equals to 4 into 22 by 7 into r square. Now this 4 and 22 by 7 we will transpose its side to the left hand side. So we will get r square is equals to 154 into 7 by 22 into 4. So you can see 4 and 154 are numbers are multiples of each other. So we will get, if we cancel by 2, then 4 will become 2 and this will become 77. Again, if we cancel by 11, this will become 7 and this will become 2. So we will get r square is equals to 7 into 7 by 2 into 2. Now there are two ways we can do this. So after multiplying and dividing by 4, we will get 12.25. Either we can write r is equals to root under 12.25 and then find the root value, or from 7 into 7 by 4 into 4 we can find the root of r squared. So first let me explain the one that I have written with red ink. So r is equals to 12.25. Now 12.25 is not a perfect square. How to find a number which is not a perfect square? So we will write like this, 12.25, and we will take the numbers in pairs from the right hand side. That means first pair will be 25 and next pair will be 12. Now in this pair, first pair of number is 12. We have to find a number which is closer to the number 12. That means 1 square is 1, 2 square is 4, 3 square is 9 and 4 square is 16. So 16 becomes more than 12, so we cannot take 16. We have to take a number which is smaller than and closer to 12. So for that reason we are going to take 3. Now 3 square is 9. So we will write 3 over here and 3 in the quotient place. And 3 into 3 is 9. So below 12 we have written 9. Now 12 minus 9 is 3. That is the 3 I have written below over here. And this pair 25 will also come at the bottom. So we got the number 325. Now the Now we have the first term as, the first one is 3 into 3, 9, and the remainder is 3, and the next two pair of number is 25, that also comes at the bottom. Now before 25 there is a point, so the point also goes to the quotient. So we have 3 point, okay, at the top. Now we have the number 325, but before multiplying we have to bring the divisor. So the divisor will be 2 times the number in the quotient. So the number at present is 3. The number at present is 3. So 2 times 3 is 6. So we have written 6 at the place. Then now we have to find a number which is closer to, and either closer to 325 or equals to 325. We have already 6 with us. Now we can get numbers like this: 61 into 1, 62 into 2, 63 into 3. So 61 into 1, whatever number we bring at this place, the same number has to be brought in the quotient. This is the way we find the roots of numbers. So 61 into 1 is 61. 61 into 2 is 124. 61 into 3 is 189. 61 into 4 is 256. And 65 into 5 is 325. So we got a number which is equals to 325. So that number is 65. So besides 6 we have to write this number 5. So we have written 5, and in the quotient place also we have to write the number 5. So 65 into 5 is 325. We have written 325 over here and subtracted it from 325. So the remainder now becomes 0. So the square root of 12.25 is 3.5. So this number is your square root. So you have written 3.5. Now this is the one process that you can use. The next process was, I have written r is equals to 7 into 7 by 2 into 2. As you can see over here we have got this one. 7 into 7 into 2 into 2. This is square, r square. So r will be root of 7 into 7 by 2 into 2. So the numbers are in pair. So from 2 7 from numerator, 1 7 will come out, and 2 2's from denominator, 1 2 will come out. So we got 7 by 2, which is equals to 3.5. So our r is equals to 3.5. So these are the two ways where we can find r square. First process is to find the square root of the given number using the long division method. Long division method. The one I have showed with red ink, this part. And the second one is 7 into 7 by 2 into 2. This part is what we got after simplification. So here we are lucky enough to get the numbers in pairs. So we could take it outside of the root and find the answer. So these are the two methods of finding square roots. So today we have discussed question number 4, 5 and 6. I hope this short tutorial is helpful for you. Thank you.